All right, so now we're on page 471, Unit 8, Lesson 7. We're going to look at this next part. So as you can see here, if you want to hit pause and just kind of look at what I'm doing here. In this example, we're just finding the axis of symmetry given the vertex form. And I've always said if you have the vertex, you have your AOS. So if you just look at the values that are in the parentheses happening to x, you just take the opposite and that's your line of symmetry. So easy enough to do when it's in vertex form because it's something that you get just by looking at the equation. So again, it's just something you get the vertex and the AOS. All right, so the next part is that what if it's in standard form? So if it's in standard form, then how do you find the axis of symmetry? Well, to find the axis of symmetry, as I'm playing with this, you have to you can use this formula, x equals negative b over 2a. So if you guys have your foldables, you'll see that this is in there, and it's a good tool to keep up with. All right, so x equals negative b all over 2 times a. So the first thing we want to make sure is that y is by itself and everything is on the right side, or it's just basically on one side or the other. So here you're going to identify a as a negative 1, b as a positive 2, c as a positive 2. Just like we've done in the past when we've had to multiply a times c and b on the bottom. So with that, we're going to go ahead and plug into the formula. X equals a negative times b all over 2 times a. And I'm going to go ahead and plug in b goes on top, so b is a positive 2. A is a negative 1. And so when I simplify this, a negative times 2 is a negative 2. And then 2 times a negative 1 is a negative 2. And a negative 2 divided by negative 2 is a positive 1. So we would say the equation for the axis of symmetry is that x equals positive 1. All right, let's look at another example. Here we can identify a equals a positive 1, b equals a positive 10, c equals a positive 24. So I'm going to go ahead and plug in again, but I'll do a different color so it doesn't mix in with the problem above. We're going to go x equals, and think of it as like a negative 1 times b all over 2 times a. Hence is why a lot of people will say the opposite of b, because that's what the negative will do, all over 2 times a. So when we plug in, b goes on top, b is a positive 10, and a is a positive 1. So a negative times 10 is a negative 10. Divide that by the product of 2 and 1. 2 times 1 is 2. Negative 10 divided by 2 is a negative 5. So we would get the line of symmetry at x equals negative 5. All right, let's try one more, and then I'm going to have you try a couple. All right, in this example, again, a is a negative 1. B is a negative 4. You could see how important signs are. And C is a negative 2. It's just important that I know what C is as well. All right, so I like to open up a frame. So x equals a negative all times b divided by 2 times a. So again, b is a negative 4. A is a negative 1. So that's why I like to open up parentheses, because sometimes when b is negative, people think that the negative in the formula represents it, which is not correct. It's a negative 1 times b, and if b is negative, you have to include that. So now we're going to go ahead and go a negative times a negative is a positive 4. And then 2 times a negative 1 is a negative 2. So 4 divided by negative 2 is a negative 2. So we would get our axis of symmetry is at x equals negative 2. There you go. All right, so why don't you go ahead and hit pause right now and then try D, E, F, G. All right.
Are you recording?
Yes. All right.
I wish you would record in the other room.
All right, so the last, for your homework problem set, you're going to go ahead and just try numbers 6 through 16. And what you're going to do is determine the axis of symmetry for each quadratic equation below. So notice that here, you're going to use the axis of symmetry formula, x equals a negative b all over 2 times a, because it's in standard form. It's not in vertex form. Well, it kind of is, but I'm not. It's kind of in both, I should say. So you would use this formula for number 6, 7. For number 8, because it's in vertex form, you know the x value is your axis of symmetry. So just be aware of those things. All right, so you guys are going to complete 6 through 16. For numbers 15 and 16, for each graph below, state the vertex, axis of symmetry, and write the equation of each function. So you're just going to list the vertex, and the axis of symmetry is at x equals 3. So if it's at x equals a positive 3, the opposite of a positive 3 is a negative 3. And then the vertex is at negative 4. And so the vertex together is at 3, negative 4. So I went ahead and walked you through that problem, so you should be able to apply those principles to number 16. Go ahead and take a picture of numbers 6 through 16 and submit, where the assignment will be ready for you.